So I'm going to record this screen and then make it available. This is the climate data analysis worksheet. It is shared on your Blackboard. Please do look into that. All right. I'm going to zoom this a little bit more. So Goddard Center for Space Studies, is situated in New York City. It's kind of like a hidden location, and they maintain a lot of data for global analysis. Primarily, this one is the climate data set that will be looking at. So climate data, whenever you are mentioning it, it's like a standard is about 30 years, okay? Because climate is a slow system. There is a difference between weather and climate. Can anybody tell me what is the difference between weather and climate?
Weather is like day-to-day phenomenon, for climate is much more stable and long-term.
Long-term average of that. You're going to say that, right? Very good. So in order for it to be called climate, it means the data set to be climate data, you have to have a long-term record of it. And I would say 30 year is a good number to have. All right. 40 year, if you have it, good. 20 year plus is gonna show you know, some kind of a pattern and trend and average behavior. So, 20 plus would work. 30 year is like a being safe and, making sure that we have captured all the events that can happen in that area, right? It's like about half lifetime, right, for a normal person. So we will be downloading the data using the Google spreadsheet, primarily because I like Google spreadsheet, not an endorsement, but it's a uniform. So Excel spreadsheet can be tricky because different computers might have different versions, right? So the way to do that is we will first download the data. We will look into the climate classification for the place that we are working on. So you can see that there are like a different climate classification, indicated by the color here, A, B, C, D, right? There is like a different mix of tropical, dry, temperate, cold, and polar climates. So you will be doing analysis from each of those climate types, and we will discuss a little bit of the examples that as we do, we're gonna go. So you can refer to a location, for example, and then you can take approximate climate from that, right? For example, if I'm looking at Florida as an example, depending upon which side of the Florida you are looking at, right? You're looking at this green, which is, temperate, right? And then if you're on this lower half here or lower quarter here, that's like a tropical kind, right? So depending upon where you are, you can approximately take that. Okay, you can visually inspect it. I'm not going to be totally strict about that, but just try to your best. Like if you are in the Sahara region, obviously that's a dry climate that we have, right? So just be aware of those. There is a gradation of different kinds, but it's called Köppen classification of the climate. Um, this is interesting because there is a newer version of that is coming up, and previously there used to be certain kinds of classification, and as a scientist, it's good to see that there is more diversification on that classification. So the data set that we take is from the GISS data. Let me show you the example. So you can basically click on the link that is active there, make a copy of this. Okay, so you can make a copy by going to the file menu and then make a copy. When you do that, you will have a copy to yourself. That way you can make the edit to the document as you process your data. All right. So make a copy. Number one, the website is there, NASA GISS, and on that website there is the globe that you're looking at, right? So I, again, as I said, I would prefer the data set that exists. Like, I'm gonna just pick 1980 January through 2025 January. And if I update that, you see that the map is updated a little bit. That kind of shows the time in which the data is included there. Okay, these are the stations. These are the stations, individual stations that are collecting the data for a long time, So pick your favorite city, pick your favorite time, favorite location, and then we will be updating those in the spreadsheet that is included. So that works it. has a spreadsheet at the end, we'll be recording our observation there. So back to the data. Stop me, please. Okay. Over here, this is the Canada here, right? Elora Research Station. There is a latitude, longitude there, and then I want to see the plot. So when I click on generate plot, I see it has the data set, right? And then that's from 1970 to 90, and then about 2000, I don't know, maybe 2005 to 2020. So this, there is a gap there, and it could be because they had problem with the station funding cut, right? That sounds familiar term, right? So could be that, could be staff shortage, could be the instrument died, right? So there are a lot of things that can happen in the ground station when you are, maintaining the long-term data. But if that looks reasonable to you, what you can do is you can download the data. And also, if there is a lot of variation, that's also spooky in the meaning that maybe there is, that location is not very good representative of, whatever is happening there. Maybe it is like a near some happening place, right? So just be careful about that, but we will be taking the average and then average data, and it will wash out usually. So I'm going to go to another location just because I'm like a suspicious about that location, right? So Portugal, maybe, let's see. So generate there. All right. Okay, that's, and it's a continuous record from 1900. That's cool. How do you get to 1880, right? So you can think about that, right? But the nice thing is that there is data. Isn't that cool? This is really long-term data. I love it, right? And, the way to download it is to click on that CSV, okay? Click on that CSV, and then you got the data in this there. That's the CSV data we got. Downloads. And I'm going to open the file. So that's my CSV data that is coming up. Okay, that's the data. So the data that we have has a couple of things here. The first column is the year, and then after that 12 months there. Okay, this is where I get questions some of the times. This is 3 months mean: December, January, February, and then March, April, May, right? And then June, July, August, September, October, November, and then MET-ANN means that's the annual meteorological mean. All right, annual mean, meaning that for that location, what is the mean temperature? So it's literally a thermometer sticking up in the air, collecting the temperature data. All right. And then they have done the monthly mean. And some of the times you will see that this 1927 has a lot of 999, right? So the question is, what happened there? That 999 flag indicates that during that time, the station did not work properly, or the data quality is not up to the standard that the NASA maintains, right? Sometimes what can happen is that the reading on the temperature can drift. Just like, your wall clock sometimes does not indicate the time because the battery died, right? So if you're looking at it, it's 4 a.m. all the time, right? So that means that if you're reporting that data, right, it's not going to be right. So what do you do? For that time, you put 999 because that data is not reasonable or of the quality. Okay. So that's called quality flag. All right. We'll be removing those. There is one more 999, and this is easy to do. If you were to do like a select all, copy, right? It's like a edit, select all. Where is the select all? Okay, select all, edit, copy, for example, and then you can open up a new spreadsheet, and then you can say climate data analysis data set, right? Rough. So when you do this, you can now edit and paste. That's my data. Okay. So I basically copied it from the spreadsheet into my Google Cloud. This is better in the sense that it's not in the local computer anymore. It's in the cloud, it's in Google server.
So we're taking one of these orange points
Uh-huh.
from 3 different climate zones.
Yes, very good. Right. Very good. It's good to see that you are catching up with that, right? You have in the table number 1, you see city 1, city 2, and city 3. I should have called it location 1, location 2, location 3. But you pick up 3 different climate type, like just look into that climate classification and decide, right? One Portugal, one from, like Egypt, for example, one from South Africa, one from Australia. You pick your favorite location where you want to go for vacation, and then pick up the data set. So I have done this. Now you can follow the instruction too. Okay, you can just like read along and then do that. So once I have done that, paste the data into the Google spreadsheet. I have done that. Now I need to remove the field data. Okay, the field data is that 999 that I saw. That's unusual, right? So this guy. The easiest way to do that is to command Control C, edit, find and replace. Find this, replace with space. Okay, replace all. And you saw that there were 31 data set that had 999.9, and that data is gone. Never replace the data with 0. That's a recipe for disaster. Okay, never replace those flag data for 0 or any numerical value. Yes, because those data are unreliable, and if you do not replace it, then the temperature, if you're measuring the temperature in degrees centigrade, right, instead of measuring temperature in 10 degrees centigrade, it will start reading in 900 degrees centigrade, and the average of 10 and 900 would be higher than 10, which is not good. Very good question. All right, so we want to replace the data set. All right, I'm gonna pause here for a second. Let me know if you have a question now. So what we have done, we have selected a random city or random location. We downloaded the CSV data. We copied that CSV data into the Google spreadsheet, right? And we replaced the flag, right? Yes.
Field data is stuff that is inaccurate.
Yeah, 999. In this data case, it is 999. Sometimes it is 49, sometimes it is minus 3999, negative 999. So there is a way for it to be indicated. And sometimes there is a data record or like a README file, and that's where they indicate. For computer science people, I hope that makes sense, right? There is like a README file that tells you, read me first, right? Okay, there is a question.
How do I get the data from one of those points?
So you click on it, generate plot, and then when you go under here, so let's say this is my location. If you go under, okay, sorry, I'm gonna go back. See, I click on that, right? And then hover over, and then you get the generate plot thingy, generate plot. And once you get that plot under here, there is a CSV, the CSV data. You can also download as a text, but CSV is easier. CSV, do you know the meaning of CSV? Comma separated values. Close enough. Right? Comma separated values. Okay. All right. So I'm going to pause here. I'm going to let you finish what you're doing. And then if there are troubles, just call me out. Can you guys select a station? Okay. Climate type, you can do that later. Select a station, download the data, and then go from there. So while you do that, can I also show you one more thing? So in this particular case, if I am collecting the data, can you guys make sure that you also make a copy of these things? The station name, latitude, longitude. So the easiest way to do that is to go into the end of the document here, Google Sheet, right? And then you can write down your name, for example, right? And then city, whichever city that was, let me not be. Ellora Research Station. Nope, that we discarded. Okay. And then latitude, longitude. So that's like that and that, north and west. Oop. Try to make it clean so that you don't have comma and space, right? North and west is fine. And then think about the climate type. You can come back to that later. So this is my one of the station that I have, right? And because I want to keep track of what is happening here, I want to also make sure that I have a record of what it looks like. So in Mac, there is an easy way to take a screenshot, right? Like this. In your Windows computer, you can take the screenshot by using print screen function, right? Or snipping tool. So if you know your keyboard has a print screen function, you can take the screenshot of the graph so that you know what it looks like, for your own sanity, right? Later. All right. So you have latitude, longitude, and these will come back in a minute. All right. I'm pausing the recording for a minute. Zoom recording. Okay. Now we are doing the data analysis for summer month, for example. Okay. What we're going to do is we're going to go back to the Google Sheet that you have done. And then if you're interested in the future, you can look at the monthly data. But for now, we're going to look into the seasonal average. This is called seasonal average because it represents the season, right? So the way to do that is first to select the column A and press the control key, right? Select A, press the control key, and then press the column P, which is June, July, August. Okay, so look at that. I have column A selected and column P selected. And to do two column selection, you have to press the control button. Okay. If you do this, then that's going to select everything, right? So you want to press one column, press the control key, and then press the other. In Mac, it is command. So do you see that? I have A and P highlighted, right? Uh-huh. Okay, which station was? Okay, can you open that again? That is weird. We can report that as a bug. But I'll tell you, in a minute. Yeah. So maybe that's another booster. Nice. Okay. Hey, control C and then you have, yeah. Let me tell you one thing. That's good. Yeah, that's what I was. So if you go back there, if you look into the file that you saw, it was a text file or something, right? So you can like count back from there. 1, 2, 3. You see? Right? And then see if the data is the same. June, July, August is like the third last data column. All right. The way to insert a spreadsheet data analysis tool here, in this case, it is a chart. Okay. So I have selected two columns, A and P. Go to chart, and then there we go. That's the data that I'm putting in. All right. I'm sorry? Yep. So first you select A, press the control key, and then select P, right? So again, I'm starting here. Click on the head here, like a top. Don't click on year, click on A. Click on A and then, swipe or like I go towards the right and then click on P. Okay, that's the easiest way to do it. If you are too much bothered by that, you can like select all these columns like this. Oops, and then you can delete the columns so that it's easier. I would not, but I'm just saying in the worst case, if you cannot at all, that's another way to do it. But for now, select the year, Select the June, July, August with the control key if you can, and then go to insert chart. And that most of the time gives you that data set. Plot it. Google is smart, so it selects the line chart because it sees that here and the temperature is on the selection, right? Okay, so try everybody and then let me know if that works. Okay, select a summer season and see if your chart pops out. I'm gonna pause the recording meanwhile. Recording, all right. So in this case, what you have here is the temperature data on the y-axis, June, July, August, and the year on the x-axis. If you do not have that, sometimes what happens is that the Google Sheet just grabs the column and then it puts 1, 2, 3, 4, 5, 6 on the x-axis. That's not the year, right? So we want to infer the year from the data here. That's why we want to make sure that x-axis has the year, okay? Make sure that happens. You can click on that and then you can see when you do that on the setup axis, x-axis is set up as year and y-axis is set up as that. Sometimes what happens is that it can mesh up and you can have that setup where you have year versus year. You need to change that, okay? You need to make sure that your y-axis, in this case, they call it x-axis and series. So you want to have that. You don't want to press aggregate there because it's gonna, sometimes mess up aggregate data. You want to change the chart type, but for now, instead of this, like a column chart, I think the line chart looks nicer, right? For inference. Now, what we're gonna do next is we're gonna, like with the graph selected, if you have multiple graph, you can click on one of the graph. You can change the line color as you wish, what is the color of the summer? Maybe like, that, I don't know, right? There is a circle, triangle, like a different designation that you can have. Line thickness can be, 4, 5, 6, 8, whatever you like, right? Opacity can be changed. It could be dash, dot, line color could be red. So, you can change the features of that graph as it looks, okay? And then the next thing that we're going to do is in the customize is, this is very important, trend line, okay? We're going to include trend line. The line color, I would put dark red, maybe a little bit thicker, right? And then label is equation. I don't want R square, okay? Just equation. So this is the important part. And then that is also indicated here, right? So on the customized side, you go trend line. And once you have the trend line, right? Once you have the trend line, in the label, use equation, and that displays the equation right there. The equation that is displayed here shows the rate of rise of temperature from that to that. That's like a gradient, rise over run. That's like 0.01 per year. In 10 years, it's 0.1. Okay? In 100 years, it's 1. Does that make sense? Right? Right. So that's why they talk about 1.5 degree centigrade change. That's what they refer. Oh, so in the customize here, you have this line type. Yeah, you can do that. Yeah, I also made it bigger.
Square.
Yeah, and then I also made it bigger.
I have a question.
Yes.
Are we gonna be doing a graph for each like season?
Yeah, and I will show you how to.
Oh,
You can do that easily, a lot more easily. So here is my selection. Look, I'm telling you, making a graph perfect is a battle that you will never win. Okay? I have had collaborators who always were very finicky about how the graph looked. And I knew going into that room, it's like that battle I'm not gonna win. So it's like, okay, what do you want? I was like, okay, what kind of graph are we looking at? I will just, because that's something you can never make. It's like a design problem after that, right? Setting up the background of a computer, Sunday blue, Monday white, Tuesday black, No, this is fine. It's a free country, man. Pick your, yeah, you good? You got it, right?
So
Yeah, I mean, again, if you want to do that, like instead of click on the data, like graph there. Yeah, and then you can select the line gas type as Like that, yeah, that's what it's on. Okay, so just keep the note of what you have, and again, you're not being penalized for how your graph is like looking thin or thick, right? Make sure that it can be seen, and you're good. All right. You can also do the following. Okay, hear me out. You can also do the following. You can insert the graph. Look, the graph can be its own sheet. See that? Because I have one data set, right? And then I have one chart. So sometimes it's like a station one and then chart for station one, So you can move the graph from there to its own graph on sheet. So that looks bigger, better, nicer, right? Less occupying. Yes.
How did you create it now?
Oh, yeah, customize, click on label, yeah. And then use equation. There we go. Okay.
Which one?
So that trend line is something that you are reporting in the, right? Do you see that? The trend line is something that you're reporting in the table. 0.0118, right? So on that table, for example, you see that? This is city one, right? I'm looking at the summer, city one. The trend for summer is 0.018 whatnot, right? 118, sorry. All right. Questions? Since you have done nicely for one, let me show you how to do that all together at once. Yeah. Oh, yeah. Customize, trend line, label, use equation. Use equation. And then,
Goes back.
oh, okay. May I?
Yeah.
So,
Oh, it's that.
your text color was white. So it is hard to see white and white. Just the rate. I don't worry about the other part, the intercept part. So this is y equals to mx plus b, right? Rise over run. Anybody else having issues here? Please let me know now. You know what I'm doing, right? So I'm selecting the year, column A, and then keep the control button pressed, and O, P, Q, R, and N. Why I'm doing that? Because now I want to like show you how to do all of that at once. So you can do that. Insert, chart, boom. There we go. So now you have all of that data. This one is annual, so I'm going to do a black color here, right? So that it is distinct. And the others are also visible. So you can play with that now, right? Line thickness, 2-point triangle, like now you can hide that battle if you want, okay? So this is June, July, August. This one is September, October, November, right? And then this one is March, April, May, springtime, and then this one is winter. So you can see as the temperature climbs up, look, this is my winter time, springtime, right? And then fall time, summertime. It's like a different season represented there. And the average of all that is there. That's my average data. And this is the data that you hopefully saw in their spreads, in their graphs. Okay, there is a question here.
Why do it like this?
Yeah, something is wrong. You probably hold on. Nothing. Okay. Did you collect? Yeah, you did not select the year. You did. All right. What do you insert? Because it tries to be smart sometimes. So it will- and then go up. So you do the line. So your there is 999. That's somewhere something.
Oh, just the annual.
Yeah. Okay. That's not always happens. Okay. So you might have selected something else, you know. Okay. Now, once you have the graph, you know how to insert the trend line, right? And you're done. So your first city is done. Look, I'm gonna go to customize, right? I would select the data. I would, right? Any of the data that I have, like, and then customize, trend line, and then insert, use equation. So for that, yellowish color, I have the June, July, August trend. I'm gonna select green. I'm gonna go to trend line, use equation. So for my green, there is immediate next line is my trend line. I'm gonna go to black. That's my annual. I'm gonna include trend line, use equation. There we go. And then because it looks like this, I'm gonna change the color for this one as dark one. So line color is this dash type, and oh, that. Okay, trend line color needs to be dark. Okay, good. Okay, and then I can select the red, go again, trend line, use equation. There we go. I'm not interested in R square for this one. So trend line, use equation, and boom, I'm done. All right, I'm pausing the recording again, just so that I can. This is the real thing that you are submitting, right? So you have done all that analysis, you went, like if I were to delete this, what you have done, look, you have selected that, you went into insert, you inserted chart, and then you went to customize. This is one of the easiest way series, and you can like enter the, not error bar, trend line, not show the R square, use equations. Wow, that doesn't look good, but you got the idea, right? You have a nice looking graph, right? I even have the data label there, you don't want that. You got the idea, right? You can also have it on its own sheet here, right? So that way you have every season, the trend line, trend, every season trend, every season trend. In this case, this is positive, okay? 0.01, 0.01, 0. That's positive. Sometimes it can be negative too, okay? Sometimes the trend can be negative too, and that's not scary. It's okay. Whatever you get is whatever you report. Okay. Once you have that, you have to, yes, manually type it in here in this city, right? For annual, winter, summer. So you have to manually type it in here. So now a little bit of detailed work here is to that you have to use the Google map to find the latitude, longitude of that location. Yes.
So we don't need the smaller chart, we just need the big chart.
Oh, it's just a preference. I just inserted it like this because it's easier to show me. For your report, you can just like use the data that you get, right? The graph you get, and then you can just copy and paste from there. Okay. So I just want to show it here because it's easier to, right? Download, delete, copy, so that's easier to deal with. So things to do. Use the Google map. Like for example, my data was collected from a station, right? So I would basically copy this one, right? And then Google map, and so find that location, right? That's where it is in Portugal. So an interesting thing about this map is that you can, have different kind of settings. I would keep it in the satellite, and then here you see that on the bottom right here, you see that 10 mile, right? So keep that about 10 miles so that you can see the surrounding. Don't zoom in too much because this does not give me a lot of information about the site. It's like, oh, well, right? This does not give me like a much of the details, like it's somebody's kitchen table. I don't know, and then this does not tell me anything either, right? So you want to have a better balance. somewhere in between, So right now it is right bottom right here, 200 feet, scroll it out until it is about, 10 mile. So it kind of gives you a bigger overview, right? You see that on the bottom, you see 10 mile here. So this gives me an idea of the location, where it is located, right? I can almost tell the country. I can almost tell the coastline, the different kinds of land feature there. There is a jungle, there is water, there is, urban area, right? If you want, if you are, good with this, you can also use different kinds of terrain or traffic, it's like, but make sure that you have that 10 mile there, okay? Take a screenshot of that and then insert it in your report, okay? So I would, as I'm doing that, like let's say, Control Shift, Control Command Shift 4. So this gives me an idea about, again, I'm doing it roughly, and then I can insert the map here, all right? In that map, I have the location of this guy, right? And then I'm inserting that here. Okay, for now, I'm doing it rough, okay? So screenshot of this, right? Indicate the climate type. So Portugal, and then if you look into the climate data type, where did that go? So over here, that looks like a temperate zone, right? So climate type is temperate, right? And then seasonal and manual trend. So that's where you're gonna put it in here. Discussion for each graph, including the average of this. So you basically, you want to have a brief discussion about, so what do you find, for example, right? Is there any difference, like, if you look at that, do you see that on average, all of the seasonal as well as annual means are drifting at 0.011, right? So I noted that the rate of change of temperature is 0.011, on average. That also seems to agree with seasonal means. Just mix, synthesize some kind of analysis, some kind of insight that you get. It doesn't have to be a big paragraph, okay? As much as you can get. Does that make sense? Some of the times what can happen is that your winter time change could be different than your main annual or the summertime change. Just look at it, right? As you expect, summer in northern hemisphere is warmer than if you go to Australia, that you may see something different, right? Okay. So summer is higher temperature. You can write that. Like think of this like you are describing this data to a friend, right? If they are looking at it, and then you say this, and they will be like, "What?" Right? Now you are telling. What are you telling them? Right? Explain some of the salient feature of this graph. Small paragraph, right? Do not write like a Shakespearean essay on that. A summary would be like a summary of all of the details that you have after the table. So you can say, in this assignment, I analyzed the data for 3 different cities corresponding to three different climate types. And by looking at it, I can tell that the rate of change of temperature across these places, across different climate zone is different. How different, right? For example, is it that the Arctic region, right, is warming up faster than the equatorial or other climate type? That's the kind of question that you want to think about. That's the discussion that you want to put in there. So that summary discussion, right? A summary discussion would be the discussion overall for the data that you have. So in your report, you should have a written summary. You closely examine the trend in temperature for station that you have collected for 3 of them, right? And also compare the seasonal differences, whether in my case, I was, lucky that I had 0.01, 0.01 kind, right? But in your cases, it could be different. Just explain that. If it is same, that's fine. If not, it's just explain, right? given the location, economic and agricultural activity, and what could be, significance of this study. What is the significance of that change, right? Think about it and let me know if you have any other questions. All right, once you are done with this, okay, this, do not write this, okay? This is a summary of the document, blah, blah, blah. No, write a better one. Okay. After you're done with that, you're gonna go file, download, and PDF. Okay. Oops, sorry, I forgot to tell you. That okay. Indicate, include a graph. So in this case, my graph would be this. Copy chart. Control that. Link to spreadsheet is fine. There is the graph, right? And then I would say figure 2, right? Climate data trend for the city. You can do print screen. On the computer screen, there is a print screen button.
Oh, yeah, I tried that, it's not. You have to
You have to function. You have to use both hands.
Windows, then the FN, and then print screen.
Like including your second screen. Once upon a time, Beethoven was so mad that he wrote a music that you have to use both hand, both foot, and your nose to get that note right. So taking screenshot is sometimes that. You know what I mean? All right. So you have that, the city of Lisboa. How do you say it? Please don't be offended, Portuguese friend. All right. And try to describe anything there. Okay. Anybody with Portuguese? Sorry. I went to Brazil once and everybody spoke Portuguese and there was I'm saying it on the record, I'm not gonna say it now. All right, anyway, so you have the things to have. You have a plot, you have a graph. Make sure that you are working on your own copy because I will be deleting things on this one, so you will not be happy. Okay, make a copy and then make sure that you are working on that. All right, once you have done that, this is the thing to do. Download a PDF. Okay, so it will see that it will give you a PDF. So that's the report that you are submitting. How do you upload that? Thank you for asking. So you basically go to the Blackboard website, right? On the Blackboard website, under the module, you click on that. I'm going to do student preview. And this is what it looks like. And then there is climate data analysis submission file. And then there is instruction if you want. There is a grading rubric there, right? So you want to check in whether you did all that thing that they were expecting. You can do view instructions, right? And then, there is an attachment type. And there is, no instructions added, probably because it's there, right? And, there is the attachment button. Can you guys see the attachment button here? Attachment there, download and climate data, open and save. All right. There we go. And submit. All right. Do it before Sunday evening. Submission was successful. Once you have that, I will grade it and you'll be happy. I'll be happy. Questions? Okay. Now let me take a 10-minute break. You deserve it now. Okay. And then we will connect to next class because there are a couple of things that we need to do. I will indicate those and then I will also give you instructions about how to finish up my module so that you will be independent and free from me until you are assigned to my group for working on the project. All right, I'm gonna stop here. Feel free to look into this recording, please. Feel free to talk to each other This is problem solving mode, okay, guys?